Hi, I'm Eric from thecarbondoctor.com. Today we're going to be talking about Grignard reagents. So, what are Grignard reagents? Well, we typically make them using magnesium and ether. We make them from alkyl halides. So this is going to be your Grignard reagent here. And we're going to start with some alkyl halide, hence the reason I used X over here, because typically you'll see them as either chlorides, bromides, or iodides. By doing this, we now allow this R group, this carbon, and we'll put some real stuff in there in just a minute, but we allow this carbon to take on this very negative partial charge. And so this Grignard reagent then behaves almost like this guy over here. So there's two consequences for this. Number one, of course, this is going to be strongly basic. The second part is it's also pretty strongly nucleophilic. And so we can use these to then add to electrophiles, and carbonyls are one such type of electrophile that we can use this with. So, the Grignard reagent or reaction takes place in two steps. First step is the attack of a Grignard on a carbonyl. Alright, that's typically what you're going to see it used for. And then the second step is going to be protonation of the resulting alcohol that you're going to get. And we'll walk through this mechanism in just a minute. So, watch out though. Remember I said that Grignard reagents are strongly basic, so you can't have acidic protons hanging around. They will destroy your Grignard reagent. So, things like no OHs, those aren't good, right? No carboxylic acids, no alcohols, right? No NHs, right? These aren't good. No SHs, things like this, right? Those all affected. Also, thinking about this, if you're trying to do a Grignard reagent with a carbonyl, you want to make sure that you're not doing something on here that has a carbonyl either. That also won't work. So as an example, this or this cannot be used to make a Grignard reagent. So now, let's talk about our reaction and what's going to happen here. So remember, Grignard reagents or reactions take place in two steps. So we signify this when we are drawing these reactions up. We signify this by putting a 1 and then a 2. We're going to add acid at the end of the day here, right? So this tells us, in this case, that we do all of one first, and either we do 2 in another reaction vessel, or we add it directly to what we have, but only after reaction 1 has completed. Okay? So now, let's talk about making this guy up here. Right? So typically we're going to make them from alkyl halides. So let's take bromobenzene as an example. So what we can do is we add solid magnesium in diethyl ether to this to allow this to take place. And so what's going to happen in an exothermic reaction, we can form our Grignard reagent. Now, it's important to note that we're using ethereal solvents here because those help dissolve our Grignard reagent. Right? So if we look at diethyl ether, with its lone pairs, this is going to have this partial positive charge, this is going to have a partial negative, and so this is going to help solvate our magnesium in solution to help keep everything in solution. So let's do a Grignard reaction using our 2-butanone that we showed earlier. So first, of course, we need to make our Grignard reagent. So once we make our Grignard reagent, we can then add this to our carbonyl of choice, and in this case, This is going to be our 2-butanone. Again, we're still in an ether solvent, in this case diethyl ether. And so now the reaction can take place. And so we end up with this. And so this is where our step 2 is going to come in. We're going to add our acid to neutralize this, and to possibly quench any remaining Grignard reagent. And notice that in this case, right, we added a Grignard reagent to a carbonyl, so I'm going to form over here a tertiary alcohol. If I had added a Grignard to an aldehyde, then I would have formed a secondary alcohol. Okay, so once we have our tertiary alcohol here, let's talk about what's happening mechanistically here. Well, first of all, we're ignoring all the inorganic byproducts that we have, and we're only going to focus on the organic products. The first step is the electrons in between this bond are going to come over here and attack at the carbonyl carbon. These electrons kick up, like so. And then once we get to this next step, we add our acid in, so we have this guy over here. And so this is what forms our tertiary alcohol on this spot. Now remember that this can happen because in any carbonyl, I have a resonance structure like this, where I can actually move these up. And now I have a positive charge on that carbon there. Right? So this becomes an electrophile at this point. So Grignards can attack here since they're strong nucleophiles. And finally, one more point on Grignard reagents that I'd like to point out to you is that when we're dealing with functional groups other than aldehydes and ketones, we need to consider something that's a special case. If I'm dealing with an acid halide, in this case an acid chloride, my Grignard reagent can actually add twice. It'll add the first way, just the first time, just like we said before, with these electrons coming in here and going up to that oxygen. And so now I have this intermediate, but attached to this I have a leaving group that's here. So these can kick down and kick this out. And so now I have this, and so again the Grignard reagent can come back in and attack one more time. Like so, right? And then this can get protonated to give us our final product. Esters do the same thing because again they have a leaving group that's on them. So if I have something like this, let's clean that up. Something like this, and I react this with a Grignard reagent. The same thing is going to happen that happened over here. This is going to go and attack. But now, since I can't really kick out an R group or an alkyl group, right? But I can kick this out. I'm already in a strongly basic solution because I'm using a Grignard reagent, so this is entirely possible that this would come out, and this is in fact what happens. And I'm back here again, which can again be attacked by your Grignard reagent. Right, so to do these reactions successfully, you need to use 2 equivalents of your Grignard reagent. Right, so that brings us to another important question. What about the stoichiometry of this? How does that work? And what if I decide to take a shortcut and instead of make this Grignard reagent on my own, but use a stock solution instead? How would I figure out how much to add? How do I figure all of that kind of stuff out? How do I know how many equivalents I need to add? How do I get to that amount? So stay tuned, because our next video will deal with the stoichiometry on this. So thanks for watching. Please comment. Let us know anything that you'd like to see that could help you in chemistry.